Not again. Yeah, sorry. All right. Let's see if that gets the whole thing. Stay. All right. So part D, what do we know about our sample? What's it say about our sample? Yeah, n is 50. Sigma is
0.54.
good. So this population standard deviation is 0.54. The sample mean is 5.23. What do I have to do with this? The sigma? I've got to change it, right? This is good for individuals. I need the one that's good for groups of 50. So the new sigma is going to be the old one divided by square root of 50. I like it. Uh, 0.008. No, I don't know.
0.076.
107?
6.
6?
4.
4? Cool. It's always 3 places, 3 non-zero places out. All right. So now I can make my z-score, can't I? And the z-score formula really never changes. It's always my data point minus the middle divided by the standard deviation. Always. So what's our data point? 5.23. That's what we found, right? Minus what they think. 5.4 divided by the new standard deviation. That's gonna be like 2 point something, 2.7.
Negative 2.23.
Negative 2.62. Okay. So what does that mean then? Where did we end up? That's my z star. Sorry, it's my little z star. So here I am at negative 2.62. It's lower than that, right? It's here.
That's not what I got.
Oh, okay. Let me see. What'd you get?
For the z-score, negative 2.23.
And that would definitely change things. Let me see. 5.23 minus 5.4 divided by 0.0764. Yeah, 2.23. Okay. So don't give me too much credit. I can sometimes do this in my head to get close, but please, dear God, let me know if something's not quite sitting well. So whoever got the 2.6, can you see what might have went wrong? You gotta be careful with how you put that in there. Okay. Hopefully. That's kind of cool, actually, because I was in my head, I was like, damn, I was hoping for one that wouldn't work. I sort of gave it away here, but that means I'm here then, right? There's negative 2.23. So what did we succeed or fail? Failed. We failed to do what? We failed to reject HO. We fail to support H1. We failed.
It needs to be more to the left, and it's not. And
Exactly. How far did it have to get at least? Or more than negative 232, and it only got to 223.
Okay.
Didn't get far enough away. Right?
So if it was 2.62, just
Then it would have been, we would have succeeded. We would have rejected the HO. We would have gotten far enough away to say it's not here, it's actually a little bit lower. Okay. Yes?
So then would you say, like, for that question, then our results suggest that the sample group isn't a good representation of the true population?
Since we failed to reject this, and so it might be from a sample that's more than 5.4, right? And which is a value often used for the upper limit of the range of normal value. That means that that group is above the normal range. Something might be wrong with them, right? Possibly,
So
or
they're
some
not
of
a
them
good
anyway.
representation.
So before we get there, let me come back to that in a second. What's the p-value before we get too far away from this? How do you get the p-value? Yeah, the area and the tail of my z-score. This is kind of nice because if I look up negative 223, it is the area and the tail right? So the negative z-scores are nice.
Quick, go for the p-value again. It's
Oh. It's the area in the tail of the z-score we found. So if we look up negative 2.23 in the z-score chart, that will tell me the area below, which is the area in the tail. It'll tell me exactly what I want. So what is the p-value? Yeah, so when you look up negative 223, 0.0129?
Yep.
Cool, man. So our p-value, 0.0129. And do you see how that's bigger than the alpha? Is it a lot bigger than the alpha?
No.
No, it's not a lot bigger, right? The alpha's 0.01, we got 0.0129. Which goes along with, were we very far away from getting to the benchmark? No, so those goods should go along. I got really close here, I got really close there.
So you take it where the farthest one is, like the arrow? Like
Our z-score is 223, negative 223.
so you take
Look that up, that's got to be the p-value. Cool. Yes?
How come in this case you didn't do 1 minus 2?
Because this is the tail here, isn't it? The other one was up here. So when I looked it up, it gave me the area below. I did do 1 minus to get in the actual tail. Yes?
Why is it negative 2.326?
Because it was down here.
How do you know?
The T chart has no negatives in it. So when you draw your picture, you got to know it's negative then.
How did you know?
Because it's on this side.
How did you know it's on this side?
Because it said less than. Yeah, cool. Yeah.
So if we are rejecting the low, do we automatically fail to support the high?
Gotta be careful now. Either I totally succeed or I totally fail. If I can say he's wrong, then I must be able to say it looks like he's right. If I can't say he's wrong, I can't say he's right. So either I'm good everywhere or I'm bad everywhere. Bottom line, right? So which one of these is the claim? Let me just finish this up real quick. Which one of these is the claim? The high in this case again, right? So I want to word my conclusion based on that.
I'm trying to figure out the V star. Is it the sigma 0.54 or 5.4?
What? Oh, let me see. Sigma was 0.54, yeah.
So on the Z star, the equation, I can't see that part. Is it 0.54?
No. Why not? Because that's the standard deviation for individuals from the population. So the first thing we had to do was change the standard deviation. Take the old one divided by square root of n, which is 50. And we got 0.0764. That's what we divided by here, right?
What's the 5.23 minus?
That's our sample mean, right? Minus the mean in the claim to see how far apart they are, divided by the standard deviation to see how relatively far apart they are. And they weren't relatively far apart enough. Yeah.
And what is the point of finding this p-value after we already
Because like,
failed?
I understand totally, because when I first started teaching statistics, I was only in the math part of it. So I'm like, why the hell do you need p-values? Like an extra step. I already know the answer. When really, in reality, like, you're never given an alpha. You report the p-value so other people can make up their own minds about it. And in business, if you're going, anybody going into business, believe it or not, p-values are used very often. Because in business, what are you always doing? Analyzing the market, seeing what the hell's going on. Is there evidence that people have decided not to buy this kind of thing? We should stop making it make something else. I mean, you're always looking for evidence based on what people are doing. So you use p-values
We
everywhere.
don't necessarily need it for solve this.
Mathematically, you don't need it.
Okay, okay.
In the real world, you need it. Yeah.
So the Z star, so your conclusion would be that
So last step.
Oh, I'm sorry.
Before I lose everybody, we have. Did we find or not find? We failed, so we have not found. Because we failed, we suck. We have not found sufficient evidence to do what? We want to word our conclusion about our claim. Which was our claim? The high. So we failed to support it, so we have not found sufficient evidence to support the claim that whatever the claim was now. Totally forgotten.
The age, that average age,
No. It was the blood something or other. The average blood cell count is less than 5.4 yet. Support the claim that the average blood cell count less than 5.4.
You don't. When do you say why? Like, is that because it asks why?
The y is actually here, really. When we saw a z-score, we can compare it to our.
So are you gonna have us write it out? Like, you need to write out the y, or is that enough?
That's enough. Yeah.
what do you do with 1 minus what? What is that?
So if it would have been up here,
Yeah.
when you look up that z-score in the table, it shows you always the area below. So you have to do 1 minus to get the area above.
That was the star. And it's because he
No. So if this like